Okay, so I started pulling apart this Fluke. As you can see already, it's pretty big, it fills the frame. So there you go. I found out what was rattling around inside it, and I'll show you. I'll tip it upside down. I found lots of screws that are loose, so I think someone's been playing with this already, which is always concerning, but there's no obvious signs of any damage or anything like that. So I found these bits of standoff spacer here floating around, this screw, and I think that washer as well. Something fell out and hit me on the leg. I think it was this washer. I'm not 100% sure. It could have been something else. I can't find anything else on the floor. You know, it's the magic floor pit. So that's what fell out. So this is a screw that holds this front PCB on here. So there's a screw missing from there, and also where one of these standoffs are broken, there's a screw missing from there also. I haven't taken the top side off yet to have a look at that, which is what I'm just about to do. I found the front panel screws loose, rear panel screws loose. There's actually a screw missing from here. The capacitors all look original. I can't see anything that looks like it's been replaced. It's got a nice conformal coating on the back there. This gives you the winding information over here. Let's get it back in frame so you can see it. So it's got the winding here, so the various voltages coming out of the transformer. A lot of information there. All good. It says it's been wired for 240 volts, so I really hope it is wired for 240 volt and it's not just an old sticker, because I will be putting it in on the 240 volt and trying it out. Let's just have a look underneath this cover here first. But say someone has been playing with this already. The fact that I found so many loose screws, and it's not normal to find loose screws. So let's have a look. So there's a broken standoff there, and it looks like someone has tried to glue that in the past. But being, I don't know, what is that? Probably some phenolic or something, maybe. It's not nylon. It's some kind of phenolic, I think. It's probably not gluable, so, but it is just a standoff on the board. The board doesn't seem to flex too much anyway, so I'm not overly concerned by it. And as it is just a standoff, I can probably just replace it with a modern one anyway. It looks like, because they're plastic, it probably should be insulated and that kind of thing. That's not a big deal. I've got some plastic ones, so if I do need to, I can probably just do that. So one screw missing from the top, one standoff, and this screw here missing. I would have expected to find the back of the standoff, the actual threaded insert, which is normally inside the standoff. I'd expected to see that there. It's not there. So and maybe that's what fell out and hit me on the leg. I haven't been able to find it. It did feel more substantial than the washer, so it could well be that there's the little threaded insert is laying around somewhere. But yeah, I mean, I can't see anything that looks like it's failed, so that's at least a good thing. It's quite an interesting design. Big heatsink area here. I don't know what the hell's in there. Some TO3 packages of some kind. I did find a service manual for this and I've downloaded it. I haven't read it yet. As is always the way. It's got a beautiful conformal coating on it on the other side, and some on the top side here too as well. But it's not on all areas. There's bits where it's like circles where there's no coating, so I'm not quite sure what the story is with that. But on the back, it's got beautiful coating on there, nice and thick. Which can be a pain if you have to resolder stuff, but on the other side of things, it means it's well protected. So that's the other thing I've got to look for here. The handles are nice and sturdy at least. I can pick it up by that. Now, what did I say? It's got this cover there missing. These little threaded terminals. That's missing. That one there is broken. It's just slipping around the actual stud. Nope, can't even see what I'm doing. There we go. Alright, so that one there is just spinning around. It's obviously coming off. There we go. Right, same as this one here. It's come off. It's probably not a big deal. I use banana plugs anyway most of the times. And there might even be standard sizes. I can just replace them with something else. Who knows? And this one here is interesting. I'm not quite sure what's supposed to be there. I thought it was supposed to be something else, but there's like a bit of heat shrink or tubing or something around the shaft, which you then turn. So I don't know what the story is there. Maybe there's supposed to be a special pot there, which has got a shaft which goes down. I don't know. There is definitely a pot, but I need to look into that. And all the other switches seem to be all okay. This one here is interestingly marked with X's. Try and get the light on it. There you go. It's got X's on here, so I'm not quite sure why. And it feels easier to turn. Alright. These are fairly stiff. This one feels about half as hard to turn. So maybe there's an issue with that particular switch. The meter looks okay. Looks intact. Doesn't look like it's stuck. Well, hopefully not. I can't really tell. It's not. Doesn't appear to be moving, but yeah. But yeah, this one here seems like it might have a problem. I need to look at that one. So let's have a look. That is this one here, isn't it? Aha, okay, there we go. So the actual switch part is not turning. Okay, that's broken off. Right, so that actually may be what these bits are from. These may be from that shaft there. Okay, so it's probably going to be a case of me having to use some epoxy to fix that. I thought they're from the standoffs because they're the same kind of material, but looking at it now, there we go. Put them together, and we have. Hope you can get on the camera and see it. Now I'll do it down here. It's a shaft. See the shaft shape there? Yeah. This is from that adjustment down there for that switch. So that switch coupling has failed. That's what those bits here are for. That's something I'll need to be aware of, obviously. I'm not quite sure how that has ended up being broken like that, but the others don't appear to be damaged. I can't see any cracks. Those look okay. So, and this shaft is pulled out very slightly compared to the others as well. It's not as inset, which is a little interesting. Maybe it's no, that's because that's floated back. There we go. So this piece here is floated backwards. Right. So that's probably not unsurmountable. The switch part turns easily enough. It's a little stiff actually, but it'll probably be okay once I actually lubricate it and stuff like that and give it a clean and figure out which way it's supposed to go. That's the other part. That shouldn't be that hard to figure out, hopefully. That could be interesting. Figure out which way's which. Could be one of two ways. Right. So I think that's obviously an issue there I've got to watch out for. So these probably all need lubricating in order to prevent them from failing as well. That's a little bit of a shame that there's that damage there. Which range is that on? That's on the third one down, wherever that ends up being. So those on a 10 volt would be like 1 millivolt scale at a 10 volt range. So it's probably quite an important one to get fixed. But I don't think it's that big a deal. So obviously this other standoff here has been broken for some time, and it's not in here. So it's obviously been dealt with before. And maybe this front panel has been taken off because of the that switch being broken. Maybe someone tried to repair it. Looking at these handles, I doubt you can see it. This one here is bent in very slightly, as though it's been hit on that corner. The other one seems to be bent the other way. I don't know, maybe it's been badly assembled, that's possible too. So all these screws were loose. Let's just have a look at this, because it's got this plate which sits on here like this. It's got these imperial screws everywhere, so it's quite a coarse thread and everything. There we go, that's how you get into that bit. Let's see what we've got in here. Nothing too scary. So yeah, that's just the long shaft on there. There's a bit of something on the long shaft to hold it. So I might be able to get some other kind of pot in there, maybe get it down there with the grub screw and get a long shaft pot. I'm not quite sure what used to be on there. I have to have a look into that. Again, this is the minor detail. Just there, which looks okay. Wiring looks to be intact. I can't see any problems. These are just LEDs. I believe they are anyway. Yeah, I mean, it looks okay. So I'm probably at a point now where I can think about powering it up. I'll put these covers back on again because apparently it can be up to like 1,000 volts in there or something. So yeah, but yeah, this has been bent. That one's bent in slightly, so it's a bit of a shame. It's only slightly bent. It's not that much of a detail. You know, it's just we'll have to see. So I need to get a plug on this thing and chuck some power on it. I should probably do a test on its power supply as well, just to make sure it looks okay. Right, so I'm going to stop video right now and see if I've got a plug, because this one really is not right. I've got the covers back on again now, well, some of the covers. I was just trying to find a plug which I thought I had, but I must have used it already, so I don't have a spare plug. But I thought I'd show you this. Look at this. This plug, which it came with, is held together with tape. Oh my god. Brass insert floating around, almost touching terminals. That one probably would touch terminal if you pushed it hard enough. That's the live. And that the wires all chewed into because it's been getting pulled. This is, oh my god. Why wouldn't they just put a new plug on? Anyway, obviously this is going to be going in the bin. For more than one reason. One, it's broken. Two, it doesn't fit my plugs in this country. But yeah, it's just, wow, incredible. So I need to figure out how I'm going to power this thing up, because I don't have a plug. I don't really want to take one off something else, because New Zealand plugs are rubbish and they're really hard to reassemble. They are rubbish. Yeah, anyway, cheap crap basically. Anyway, badly designed. Yeah, so I thought I'd just show you this abomination of electrical wiring. Oh, there's something else too. This had two screws missing from here and here. They go into some standoffs which are supposed to hold on this cover here, right? The standoffs are basically glued to the board though, because of the conformal coating. The standoffs hadn't come off even though the screws aren't anymore. So someone's taken those out for some reason. That's interesting, you know. With that broken thing on the front, I can understand the front screws being taken out. Can't understand why the back screws are loose. So, I mean, I won't know if this thing's actually okay until I go to power it up, obviously. But, yes, I'm suspicious that someone's been playing around in here for some reason. Right, so I found this power supply which I rescued from work once. I chucked it in the bin and I fished it back out and repaired it. What is it? 5 volt 10 amp power supply. What it was, that capacitor there, had gone. Replace that and we're fine again. Anyway, so I've got this cable here, which conveniently has a plug on it. So what I'm going to do is take the cable off and put it into a joiner. Then I can at least power this unit up and we'll go from there. Okay, plug is wired up, so let's just do some tests. And let's just see, I'm going to take them away on cables, hold on. And we'll see if the earth is good for a start. Okay, stick that on there. What's that, 0.5 ohms. And lead resistance is 0.3, so it's like 0.2 ohms to case. So the earth is good. Check between these two phases here, well, earth and, phase and neutral, open circuit, phase and earth, open, earth and neutral, yep, open. So that's all good. Power switch, let's have a look for that. I'm guessing that's the on switch. See if that changes anything. Now got about 100 ohms or so going through there. What does that work out as? I don't know. 2.4 watts. Yeah, 2.4 watts. That seems reasonable. So it's not like a short or anything there. So I'm fairly confident about plugging it in. So what I'll do is I'll spin this around. And I'll do this on video. And if it goes bang, at least we'll catch it. Hopefully. Let's try and get it further forward so I can see the circuit in case something does go and I'll at least look at it again later. Right, here we go. Moment of truth. No bang. It's turned on. It's got this big ass relay over there. Okay. The meter doesn't appear to be moving, or at least not properly. Let's just try increasing these levels. I'm not seeing the meter movement. Yeah. I can see the needle moving very slightly, but not really. So let's see what I'm getting on the output of this thing. Click on volts. Cutting on the 10 volt range, and I'm getting nothing. So it doesn't look good. Appears to be dead. Oh, if I go to the right terminals on my help, does that change anything? Yes, it does. Right, let's try this again. So I'm getting minus 1.1 volts. When it's set to 7 volts. Still minus 1.1 volts. 1000 volt range is now, should be doing 740 volts, and it really isn't. So yeah, something is definitely not working on this. It may be because of that switch failure. I might have to play around with that switch to see if I can get the thing to sit right. But right now it isn't producing any output. I'm not quite sure what the relay is switching there. I'm guessing it's the main power supply in some way, but it's not always switching. Yeah, so the meter's probably giving the correct reading because there is nothing coming out. Yeah, something is not working on this. So hopefully it's not completely stuffed, considering the amount of money I spent on it. So this requires more investigation. Right, so I've done some testing on this unit here, and what I've basically found is there's voltage issues, power supply problems, multiple ones. Maybe related to one power supply in particular not working, which is probably affecting all the others. So TP1, which is the main power input to this main 15 volt regulator, is okay. It's within range. Just right, 20.8 volts, which is adequate. Now TP2 is basically a 15 volt power supply. That is nothing. It's completely dead. Nothing there. And that's what I'm actually fault finding right now, is that one. These other ones are here, but they're out of spec. So TP3 is 13.8 volts. It should be between minus 13.8 volts. It should be between minus 14.5, minus 15.5. So it should be a minus 15 volt supply. And TP4 should be minus 504. 504 volts. Should be between 540 and 600. So that's low by about 40 volts. And TP5 is 661 volts. It should be between 690 and 760. So that's also low by about 40 volts. So I'm thinking it may be related to this TP2 being wrong, and it may be throwing everything else out. I haven't looked into those other ones at all yet, but I was looking at TP2. I thought, well, I'll get that one going first. So what I've actually done, TP2 is just here, TP1 is just there. So that's that 22 volts, 23 volts supply. That should be 15 volts out there. Also, terminal 13, which is just here, is also a 15 volt supply. So the TP2 is like a reference, 15 volt reference, and which is terminal 23, and terminal 13 is also supposed to be a 15 volt supply. I've actually tried taking those connectors off in case there's a short externally to the board, dragging it down or something. I've disconnected both those wires at once, and no difference. There's still no voltage. So there seems to be an issue with the main power supply, which is just here. At least for that 15 volt supply, it's just here. Okay, this is transistors here and this circuit just there. So I'm just trying to go through this and figure out which parts are not working correctly. All these transistors have got Fluke specific part numbers by the looks of it. So I can't just look at a transistor and go, okay, it's one of these, and change it. It's not that easy, it would seem. So a 15 volt supply is not a big deal. I can probably cobble something else together and just make a new power supply to go in there. But ideally I actually get this one to work. So I'm just trying to work through this now and figure out what is going on. But say that is not working. I'm just looking at the circuit diagram for it and trying to figure out how that functions. It's got some current protection and stuff like that in there as well, so it might be a current protection fault somewhere or something like that. So that's where I am right now. Okay, so I just replaced Q20, which is a 2N3904, because I suspected it wasn't actually turning on the main regulated transistor just here. And I test over here at TP2 now, and I'm getting 14.2 volts. So it's actually doing something now. So that's a bit of an improvement. but it's still not completely fixed. Still got more issues going on. But I need to adjust this reference. I think it was this one just here. There's an adjustment somewhere, I can't remember what it is, I have to find it. So the 15 volt supply is now at least alive. It's doing 14.3 volts. Just pull these plugs off and just do another test without any loading on them and see what comes out. There's that one there and this one here. Same voltage, so it's not overloaded or anything like that. So that's okay. And go back on again. So that's one problem fixed. More stuff to check though. Okay, so what I've actually done now is I've hooked up my test leads to the correct terminals, which makes a bit of a difference. And it is now working. I'm getting output voltages. So when I turn the unit on, it doesn't like 300 volts for some reason. It might be a dodgy capacitor. But allow it to do 100 volts, 200 volts, 400 up to 900 volts DC. The meter is not working very well. It's working, but it's not accurate. Now my multimeter here is rated for 1000 volts DC, so I'm not sure if I should actually risk going that high. I'm not sure if the cable should even be. They're rated 1000 volts. I'm not going to touch them now. So that's sitting at 900 volts right now. So if I go 910, 920, 930, 940, 950, 960, 970, 980, 990 volts. I'm not going to go any higher than that. Yeah, but yeah, it's working. So that 15 volt power supply was the main issue. I say there is a secondary issue here. You hear that? It doesn't like the 300 volt setting. I'm not sure why that is. Maybe there's a shorter capacitor in there or something like that. I need to look into that part. So there's obviously a problem with a 300 volt range. Let's do that one. If I do 30 volts, it's fine. So it's not like a divider problem. Now in these settings, 10 volts is reading really closely. I need to use a better meter for this because I don't actually know if this is right. But yeah, these are reading really closely to my little Vici meter. Yeah, those are working as well. That's working as well. That's working as well. And I'm out of resolution. I've run out of resolution on the meter, so I can't get any better than that. If I go up a range, just try that. No, it doesn't work. So yeah, it's working. I fixed it. Yes. That is money well spent in. But it sounds like it's got an issue still. I'm going to have to look into what that is on that 300 volt range. There's obviously some kind of problem there. So I'm going to have to look into the circuit diagrams for that and see what's going on there. And then I'll check the calibration. Hopefully no one's been twiddling everything. And hopefully it's alright. Yeah, but it's looking pretty promising. All those voltages I've just checked have worked. It's only the 300 volt range which hasn't worked. I haven't checked the lower resolutions obviously because I need to put a better meter on here yet, so I can't do it yet. Right, just a little bit of video. I'm not quite set up for this, but I thought I'd point this out. On this one here, this little bulb here had gone. Let's get the bulb. Here's the bulb that was in there. Okay, it's just got two wires that just plug into these terminals. Just there. So they just plug in. So I've actually done here is I have I'll show you it just down there. That's it there. is I've replaced it with an LED. I used a red LED and a 2.4K half watt resistor. And now when it overloads, just wind it down so it overloads, it comes on the red LED. So now you can actually see when the limit comes on. Okay. There you go, also does that too. Alright, so that's one little thing which I have to fix. Now these jacks here, so you notice one, they're both broken. The things are gone, but they're replaceable. I could take those off and replace them with brand new ones, so that's something I'm going to be doing too. I might even have some, but I have to make sure that they're insulated, because obviously potentially there's 1000 volts on here, so, or 1100 volts or something, whatever it can be. So not good to have exposed terminals, so I need to make sure that they're insulated, okay, to make sure it's safe. And the other thing I've got to do is find a knob to put on this pot here, and then I can carry on. What I basically want to do with this now is I was going to replace all these capacitors. This one here I believe is bad. That is C1. I'm getting a really wacky measurement off that one, like 5 UF, and it's supposed to be 80 UF. These other ones are measuring sort of 123 UF and stuff like that, which is just outside the tolerance. It's supposed to be 80 UF plus 50% minus 10% is the range. So they could be up to 120 UF and be in spec. This one here is way out of spec. That's just not wrong. It's the same cap as the other ones, and it just measures completely wrong. And that is used partly in the circuit which does that 300 volt range. So I believe that capacitor is what's actually making that 300 volt fail. So that's one thing. I'm going to replace all of these. They're all these 5 terminal things, so it's a bit awkward as well, but I'll just have to make do and make something work. I'm going to replace all these other big caps as well. There's other electrolytics. These blue ones, I'm going to replace all the blue ones. So I've ordered all those, and I'll start replacing those as they arrive. So I've been working on this unit here, trying to refurbish the issues it has. I haven't sorted out the 300 volt thing yet. I'm still looking into that. But that broken shaft on here, I've managed to piece it back together. Let's just zoom in. There we go. That little round bit in there. So I managed to glue it back together. I put a coating of glue over the top of it as well. Hopefully it doesn't fall apart again. And so as you can see now, it all turns just fine. So that's that one re-enabled again. So that's that repaired. So it's one less thing wrong with it. So the only thing really that I know about now is that it needs a couple of new capacitors in it. And that 300 volt switching, which I also need to get into and figure out what's going on there. But it's not doing too badly really. The issues are relatively minor. I've done calibration on it, and it seems to be pretty consistent at least, and it was already pretty close in most ways. It's probably within spec, but I can actually get it better, so at least it's not too far off. So I started testing these capacitors, and I've already done the ones on this side. I've just changed my leads over to these clip leads, these Kelvin ones. I was going through them all and checking the values, see if I can find anything out of whack, because I only want to replace what I need to replace. I've got them all just in case. This one's rated versus 100-25, and this is 118.3. Let's actually just do this, because I want to see ESR instead. That looks right. This one here. UF 4.1. Actually, I was thinking, because I didn't have this set on an ESR before. That's APO again. I said ESR. Do this again. Use it right, shouldn't I? Right. Do it again. I'm going to start again. Hold on, start over here. Okay. The UF, the actual capacity readings have been okay. I'm just going to double check the series resistance. See if I see anything that looks completely out of whack. But everything, all the values so far have been looking good. That was 2 ohms, that one. That looks a little bit high. Might just shows that one, it's the same value, so it might be right. 6 ohms, so I mean, the smaller the value, the higher the resistance. So it's not unusual to see something like that happening. I'm not too concerned about it. 6 ohms again, it's the same. That's the same value as this one, so that's fine. 16, that was right. I do know that the crowbar circuit on this is playing up a little bit. I figured out that issue with the 300 volt section. 53 UF, let's see if I use this one. 47, so that's right. .348, I think it's a 330 that one. Yep. Not sure that one is, I can't see what it is. 15 NF apparently. Can't quite see it. So I mean, I purchased a whole bunch of caps anyway because I thought, well, I haven't got them, so I might as well get them. That doesn't look too bad. But I know the crowbar circuit is playing up. 18 4 ohms, 11.8, and it's supposed to be 10. This is supposed to be 10 as well, I think. Yeah, looks okay. So there's nothing obvious so far. All these capacitors, although they're old, seem to be testing just fine. I mean, the resistances may be a little bit high, but they seem okay. Let's just check these ones again. Seeing as I didn't have it on ESR measurement. It always catches me out, it does. I should have learned that by now. That's fine. This one here's also a 330, so I'll do the same. I saw that's a 330 there. Is it? Oh no, that one there. It's a 470, sorry. Getting myself confused now. Yeah, looks right. I've noticed the capacitor values are all on the high end, so they've all drifted out over time and got higher capacity. They're all done exactly the same, so the ratings are often like 50% more and things like that, so it's well, something weird on that, but yeah, these all look okay. Yeah, that's all those ones. So these the capacitors seem okay. I know that this one here measured funny, and I think one of these other ones, this one here, might have been a little bit off as well. So I've purchased new capacitors to go in here, but they haven't arrived yet. So when they arrive, I'll be able to look into that and do some more. What else? If there's any under here, I should have a look. I don't know if there was or not. So I'm going to show as well. This is the transistor I pulled out, one which is blown, which is although it measured okay in circuit, I want to do another measurement on it because it measured okay in circuit, but it was actually faulty. It wasn't working. Yeah, some more caps in there. So look. Right, what we got here? Cable's twisted around a bit. This hasn't been powered up for a couple of days now, so it's probably 26 ohms. That looks a bit high. Even for a 4.5 UF, 26 ohms looks awfully high. That may be an issue. So 100 UF, that looks okay. This one here as well. It's another 100 UF. Resistance is a little bit higher on this one. It's going towards the top end of what I think is normal. That I might need replacing. So I might. I've got some 100 UFs, so I'll do that one. I'm going to put an X on there, replace that one. And which other one I was suspicious of? Was it this one? It's okay there. Which one was it I was looking at? I've already forgotten. So it's waffling on a bit this video, isn't it? Come on, get in there. And that one there it was, okay. So here is out of whack. That one there. So there's two there I'm looking at replacing the looks of it. So yeah, that's a 100. And it's definitely not doing that. That one there and that one there should be the same. So let's check that again. So 0.66, 116. Slightly higher. So yeah, I'm suspicious this one's on the way out. So it might even be one of, that's the one that's in the crowbar circuit. I have to figure out what the crowbar circuit actually is. It might be over here. Crowbar might be over this side rather than that side. I can't remember where it is. I've only looked at circuit diagrams. I know these relays here are part of the crowbar circuit, so it might be on this board rather than over here. No, I'm not sure. I mean, that's power supply, power supply, switching. I don't know. I need to look into that. I think that's all the caps I can check. I mean, these ones here are, you know, a bit different, but I'm probably just going to replace all of those and have done with it. Right. Okay, that's that for now. Okay, so I've been recapping this thing. I've done probably 80% of the caps, all the discrete ones, and I've still got the 330 UF to replace, so those ones haven't arrived yet, and the 80 UF and the 250 UF caps are in here, the main big bulk caps here, obviously because they haven't arrived yet. Once they turn up I'll change all those too, but I've done just about all the other ones. There's a few there which are odd values which I am having trouble finding, like 30 UF and 15 UF in an actual package. I may have to do something else there for those, but they test okay, so I'm not overly worried about those, but I'd still like to replace everything, just have done with it, you know, so it's all good, brand new. Right. So I've got the Siglent DMM here, 6.5 digit DMM. This is currently turned off and is plugged in, so let's see what happens. What's it currently says 3000 volts, better drop that down a bit in case I zap myself or something. Alright, I've ordered some new terminals first. I'm going to replace these terminals because they're, well, not very good. Let's try and get this bit of camera in the way. Can't do this. Yeah, it's slightly better than that. Okay. Right, let's see what happens. Obviously, it's not warmed up, so you know it may not. It's not going to be 100% accurate. But the main thing here is to actually see if it works. And at the moment I'm not seeing anything. Interestingly enough. Oh, because I've got to set it to 0. That's why. I don't know. Right, there we go. 1 volt. 1 volt. Alright. Just going to go through each range. I may need to redo the calibration now, change those capacitors. It's very likely it's affected it. Let's just do a manual ranging 2 volt range. I think, or actually, no. 200 millivolt range. Okay. So that is 5 microvolts difference right now. Is that 25 microvolts difference? I've got to set to 10 placings, so If I do the higher resistance, does that change anything? No, it doesn't, does it? So it's 1 millivolt there, and yep, 1 milli, right, to 100 microvolts. Well, it's there. It's off by 26, it looks like. So this is cold, so it's not warmed up or anything like that, and that's quite important. Ah, there we go, that's why. I've got this one on 2. Yeah. Right, so that's 0 now. It's all zeros. So that's 5 microvolts. 15 microvolts. So I'll do this one, it should go up to 6. 7. Okay. 8. Yeah, I might have to do some tweaking on that. We'll see. So let's do 5 microvolts. Should be, yeah. It's up by about a microvolt. I'm not quite sure why there's a bit of a difference on that one, but it's still at such a small value. Alright, so let's do 10 volt range. 20 volts. That shouldn't be. Here we go. Took a while to catch up, didn't it? Because it's got the 100 placings. It's very smoothed out. Okay, so that's a bit auto ranging, and do yeah, 100 volts. What I really want to see is if the 300 volt range still gives me the issue where the crowbar circuit is tripping. It is. That's still happening. And I replaced the capacitors in that region too. Alright, so 400 works, 200 works, 400 works. Well, that's starting to go. So something's changed. There's still 2 capacitors in there I haven't changed yet in that circuitry, so it may be related to that. So now the 400's doing it as well. Okay. 200 isn't. 500 isn't. So I do that. So it isn't actually the 300 volt output. So that's on 300 volts right now. Okay, because I'm doing 200 plus 10 of that range, so that's 300, and that's fine. The 400's doing it. Tripped. Yeah. So between 300 and 400 volts. Yeah, I need to look into this some more. I was hoping that capacitor replacements would fix that, and obviously that's not the case. Let's just see if we do. Let's do 900 volts. The thing I have to do with calibration, once it's all warmed up properly, I've got to put the covers back on. There we go, 900 again. Okay. I expect changing caps will have changed the calibration, so I need to go back to that. Hear that rattling then as well, so that something has changed. There you go, 1000 on there. So yeah, it's the high voltage. I need to look into that some more. It's actually changed. So yeah, I need to do some more testing in that circuit to see what's going on with the crowbar and see what's triggering that to happen. If I put the limit right up, maybe that changes something. No, 400's starting to go. it's interesting that I can just make it trigger, so that's quite handy because it means I can do some testing there and see what's going on. But yeah, I mean, you can see it's pretty accurate anyway. Even though right now it's probably getting out of calibration again. I did do a full calibration on it, but it needs some more now. But, yeah, well, it's no worse anyway. It still works, and that's the main thing. So that worked as I expected. That's the limiting coming on, which is what it's supposed to do. As the crowbar kicks in if the if the voltage drops, the crowbar comes in and drops it off. And above 300 volts, it actually keeps it locked off if the limit comes on. But if you're on like 100 volts, I think it will work on there. If the limiting comes on, the limiting just comes on. It's fine. And then when you put it back up again, it doesn't actually trip. So yeah, I don't know. It works, but and it does what it's supposed to do. I just like to get this high voltage thing sorted out. You know, something is not happy there. You can hear it's supposed to. It stops on 300, which isn't what I intended. When you go between, you can hear it chattering. So it's dumping the voltage. So that's doing what it's supposed to do. But, yeah. More investigation required. It could still be because of these capacitors here. It could still be because of those. So, yeah, I'm worried about that. Maybe replacing those will fix this problem as well, but you know, it's actually quite likely because one of those, well, actually a few of them are in that circuit region, so it's quite likely that those are related to the problem. And we'll go from there then. Right, that's enough blabbering on and waffling and what have you. Not quite finished yet, but it works mostly. So I still got a good deal on it, really, I think. Even though I paid a fair amount for it, it's still cheap for what they tend to go for. Okay, so right, that's enough of that. I might leave it at that for now and come back and do a part 2 later on if I get the rest of the parts, because they're going to be a while away yet. So have a good one, and I'll catch you later, and give us a thumbs up and subscribe and share the video and tell your friends and all the usual kind of stuff I tell you about. So remember to subscribe too. If you're not subscribed, subscribe. Catch you later. Have a good one.